Hello everyone, welcome back to another video. So today we will discuss editorial for weekly contest 392 and I was able to solve all four problems. So we will see all four problems. So first problem is longest strictly increasing or strictly decreasing subarray. So we are given an array now of integers and we have to return longest subarray in nums such that it is either strictly increasing or strictly decreasing. And I don't think I have to explain a lot of things in this question. We are just given a very low constraints. There are two ways to do it. One is to use n square loop and other is using a simple greedy of linear time solution, and we just check first longest strictly increasing and then check longest strictly decreasing and take the maximum answer from both the cases. For in this, what will be the longest increasing? 1 4. So the longest increasing subarray has a size 2. Similarly, for longest decreasing, it is strictly decreasing, it is again 2. So max of 2 comma 2 is 2. Here there is only one strictly increasing subarray of size 1, and also maximum size of strictly decreasing subarray is also 1. So max of 1 comma 1 is 1. And in this third example, the longest strictly increasing subarray which has maximum size is 1, but in strictly decreasing subarray it is 3, because 3 to 1 is strictly decreasing. So max of 1 comma 3 is 3. Now you can do this in n square. So find n square or n cube, I guess, and it will probably work. So in n cube, what you can do is you can just first find start point and end point of an array and check if it is strictly increasing or there are two phases. First is strictly increasing and second is strictly decreasing, and for each phase there is an n cube solution in which you fix start point and end point and check the array subarray from start to end is either one of them, and if it is either one of them, we can uh, take that subarray as one of the answers and take the max of it as answer. And other solution is of n, so it is a greedy type solution. So I'm just making first current element as -1, and whenever I get an element which is greater than current, I update the current and increase the counter. And now if I get an element which is uh, less than or equal to current, that means we have to break here because it is not following the condition of strictly increasing. I will just take max of answer with CNT current size of subarray and update the current and CNT. And also remember, we have to also take answer with max at the last, because it will not always this condition will not always satisfy before ending the array, so we have to consider this. Similarly, we have to, for strictly decreasing, we have to perform same the operation, but this sign should be changed to decrease less than, and also current should be int max first. So this is the first question. N cube, n square, whatever you can write, this will accept. So now let's just move on to second question. So in second question, we are given, first we are given a distance formula s1 and s2 as sum of minimum distances between s1i s2i when the characters are from a to z are placed in cyclic order. So for example, we have a string s1 as ab and a string s2 as cd. Now I can make a go to b and b go to c. So this took me two operations to convert A into C. Similarly, I can make B to D into operations. So number of distance over here is 4. But there is also another possible way in which I go from A to Z, Z to Y, similarly up to uh, C. And so this is also a possible operation. So either I can increase the current character to reach the target character, or decrease it in cyclic manner. So from A, when I decrease the character, it will become Z. So we have to remember this is a very repetitive concept. I can say this is asked in a lot of questions. So this cyclic order and how to calculate both the values should be you should basically formulate it. You should be able to formulate it very easily. So in this question we are given a string s, and con uh, we have to convert it into a string t such that distance of s and t is less than equal to k, and it is also lexicographically smallest. So for example, we have a string zb bz, and if we convert this into this and z, and k here is 3. Now in one operation I converted z to a, because cyclic shift I can increase this, it will come out to be a. Similarly, in one operation I can convert b to a, because by decreasing the b. Similarly, in this case also 1. So total cost till here is 3, and z is z, so no uh, cost of operation. So within 3, within this k, given k, I got this string, and this is definitely lexicographically smallest. Now whenever you are working with lexicographically smallest, remember first character is the priority always. So let's just take this example, x c and c c. Now in lexicography order, as we discussed, first character is always priority, because if you do not let's say I can make this a, or I can also make this b. In lexicographically smallest, a will always give lexicographically smallest string, whether it has all z's after, or whether b has all a's after, because first character is priority. In more priority is given to in lexicographically smallest string, because the definition of lexicographically smallest string is first character which differs from uh, which differs in both the strings. So xcd, I have to convert this into a to have lexicographically smallest string. Now for converting x into a, there are again two options: one by increasing this, one by anti-clockwise or clockwise type. Clockwise means x to, let's say, x to y, y to z, and z to a. Or anti-clockwise might be x to, or keep on decreasing it up to a. So we have to take minimum of both of these, and if the minimum, if the current k, so we can maximum perform k operations only. So if current k is greater than equal to whatever required we have, required is minimum of both of these operations, and if it is greater than equal to required, so we can basically make this character a, and out of k we have used required number of operations. Now if k was less than equal to required, then we have to make this character as small as possible, not equal to a but might be equal to b, c or anything else. So in that case what we can do, we can either increase k by increase x by k characters or decrease x by k characters. And whenever we do this operation we have k equal to 0, we can just break now and print our string finally. So this was the logic. You should basic concept is give priority to first character, and if k is greater than equal to required, so required is basically minimum number of operations to make current character equal to a, just make it equal to a. If it is not possible, make it as less as possible and just break the loop. So if you want to see the code, I have created a copy of s as res result string, and two ways from decreasing a character from, let's say, c to b to a. So this is the anti-clockwise operation. So from making c convert into a, we can just basically take the difference of ASCII values of the both characters, which is like c minus a. Now if you do this subtraction, it will basically calculate the difference between ASCII value, and in ASCII value a b c d e to z are in increasing order. So if you do this, it will return 2, which is the required number of operations. So the required for anti-clockwise will be s of I minus a, and required 2 will be from, let's say, I have to convert c to z first. So for that, z minus s of I, and to convert z to a, there is additional one operation. This is the additional one operation, and finally I'm just storing minimum of both the operations in required. And if current k is greater than equal to required, I will just make the current character a and subtract required from it. And if it is not, I will what I can do is, I have two characters, either increase or decrease. Now this will not overflow or go below a or above z, because we have basically checked this in this if. So if c, in this case I think c1 will always be less than c2, but if I just thought we have to check two characters, and if c1 is less than equal to c2, I will just make res of I equal to c1, else I will just make res of I equal to c2 and break, and finally return res. So this was also simple question. If you have solved lexicographical questions, you must have understand this concept, priority to first element. So yeah, let's just move on to next question. Now in this question I also did two wrong submissions, because I think there is no clarification for even size array what should be median, because there are two possible medians in even size array. So 5 6, I think I considered both of them and calculated the minimum answer for each one of them, but when I saw where I'm getting the wrong answer, they are considering answer only by this right side element in even size array. So I think they should have mentioned it here, because uh, on code forces, if you find such question, they will just mention which median you are considering, either this or both, but they didn't mention it. I thought both we are considering, because if you search the definition of median, So I got 2 penalties for that. So let's just see first question. So we are given an array nums and integer k, and in one operation you can increase or decrease any element by 1, and we have to determine minimum number of operations needed to make median of nums equal to k. Now median of nums is, so let's just take first example, 2 5 6 8 and 5. Here k is 4. So median is when you sort the array, the middle element is called as median. In odd size this is, and even sized, uh, for this question we have to consider the right one element. uh, so in this case we have to make median equal to 4. So what we can do is we can increase or decrease element. Now if median is greater, there is no point increasing it, so we have to decrease this and make this equal to k. So after that, let's decrease the 5 with make 5 to 4. So cost operation here is 1. Now median is not 4, now median is 5, because when you sort the array, 2 5 4 5 6 8, this comes 5 becomes the median, not the original 5 but the 5 which was present before the uh, previous median. So now I have to again decrease this 5, so this will come out to be 2 4 4 6 8. Now I can say that we have achieved 4 as median, and total number of operations required here is 2. So key observation here is, let's take the second example, 2 5 5. First key observation is, when the current median is greater than k, we have to decrease it. If it is less than k, we have to increase it. So in this case current median is less than 7, so we have to increase this. Now whenever we are increasing this, all the elements towards right which are less than k should also increase to k. Now why is that? Because when we increase this k, we increase this to k, the right elements which are less than k will shift towards left, and the median will basically change, or will not achieve the median which we are required. For example, if I increase this 5 with up to 7, so 2 5 7 6 8. Now when we sort this array, it will come out to be 2 5 6 7 8. So to make this not happen, we have to also increase this 7 up to increase this 6 up to 7. So for that we required one more operation, and we'll make this 6 to 7. So we don't have to basically simulate this, but just for if we are at middle, if the median is less than k, all the right elements after that median which are less than k, we have to make them equal to k. Similarly in this case, if median is less than is greater than k, then all the left elements which are greater than k should also be decreased to k. So this was key observation. And in even sized, we have to work with this median. So middle element of even size array will be these two elements, but we have to only consider the rightmost element. So first, if n is equal to 1, our answer is absolute value of k minus a of 0. Now I am calculating the median as md a of n by 2. So for if let's say n was 5, it will give me answer n by 2 will be 2. So 0 1 2 3 4, so middle element. And if n is say even 0 1 2 3, n by 2 will be the writer element of middle two elements as we wanted. And if median is equal to k, I will just return 0. If md is greater than k, I will make all the elements from which are left to median and greater than k, I will just make them equal to k. And for that I have I wrote this for loop. And if it is negative, I will just take max of 0, because for elements which are already lesser than k, I don't need to worry about them. Similarly, if md is less than k, I have to make all the elements from right uh, increase to k. So similarly, I'm taking k minus a of I, but this time. And if it is already greater than k, I don't need to worry about that. And finally return the answer. So this was third question. They should have mentioned that which median to consider when there is even sized array. So now fourth question. This is an interesting question. So we are given an undirected weighted graph with n vertices, and we are also given some edges from u to v with weight w. A walk on a graph, so basically a traversal from one point to other point, is just such that all the vertices are connected by the start and end is connected by multiple edges, and we can go traverse from start point to end vertex via those edges. And so it there might be multiple vertex visited, or multi same edge might be traversed multiple times. So that's not a condition here. A walk might may visit the same edge and vertex more than once, and the cost of a walk starting at node u and ending at node v is defined as bitwise and of weights of the edges traversed during the walk. So for example, we from let's say from u and v, we are going on the edges whose weights are w0 w1 w2 and wk. So the cost can be calculated as w0 bitwise and w1 bitwise and w2 up to wk. Now we are also given a query. We are also asked some queries in which we are given starting point and ending point of starting index, starting vertex and ending vertex of the graph, and we have to return the minimum cost of the walk between starting vertex and ending vertex. So in this case, as you can see, this is the graph, and we are asked two queries. First query is to go from 0 to 3. So what I for going 0 to 3, what walk I will choose? I'll first go 0 to 1, then 1 to 2, then 2 to 1, and then 1 to 3. So basically weight 7, 7 and 1 and 1 and 7. So basically it comes out to 7 and 1, which is 1, because you can calculate the and of 7 and 1. So this is and comes out to be only 1. So here answer is 1, but there is no path from going 3 to 4 in second query, so answer here is -1. So in similarly in second case, this is the graph which we come, and for growing from 1 to 2, what path I can choose? and I can go to 1 to 2, then 2 to 1, and again 1 to 2. So 1 and 6 and 1, which comes out to be 0. Now first try to find why when the answer comes out to be -1. When it comes out when Si and Ti are parts of different components. So what is a component? Component is a, a graph, a set of vertices such that from any pair of vertices I can reach any other vertices. For example, 0, 1, 2, 3 forms one component and 4 separately forms another component. In this there is only one component which contains vertices 0, 1, 2, and so if two points are on different components, we cannot visit both of them in a single walk. That is first case, uh, which is the -1 case. Now for second case, you must have understood one concept, that is and is always uh, decreasing. So let's say I have x and I do x and y. So new value of, let's say it as r. So r will always be less than equal to x. So taking bitwise AND is always a decreasing operation. So when if you understand this, you will also understand that when I am going through two elements which are on same component, doing AND of all the weights in that component is the minimum cost, because doing AND is always decreasing. Now let's say I take AND of 1 and 6. So from for going from 1 to 2, I can go from 1 to 2, again 2 to 1, and again 1 to 2. So that is our main operation. So this comes out to be 0. But there is, if we take AND of all the ages in this also comes out to be 0, because this is itself 0. Now but when you take all the ANDs, when you take AND of all the weights, there is higher chance that this will come out to be minimum, because AND is always decreasing. So in each component, if we are iterating from for we are walking on a path of 2 points in a single component, taking AND of all the weights is optimal, or which gives minimum cost. That is basically the answer of this question. So in simple DFS, I can calculate the minimum AND of each component, and just whenever I am getting a query, I can check if both the components of both the, what we can say, both the points is equal. Then I will just return the AND of whole AND of weights of all AND of all weights in that component. If they are not equal, if they are not, the components of both the points are not same, I will just return -1. And if query of I, and if starting point and ending point is same, I will just return 0. So that is also one of the condition here. So I got one wrong answer for that. So first of all, what I am doing is I am making an adjacency list. and a sum vector. In sum, what I'm storing is and of all the weights which the current vertex is part of. For example, 1 is part of 15, 6 and 1. So at position sum of 1, I'm storing 15 and 6 and 1. If you take multiple ANDs, let's say 6 and 6, A and A is always A. So if you take multiple ANDs, there is no issue in bitwise AND. So what I'm doing is, if I just write a simple DFS, if visit if I go through all vertices, I cannot go through all vertices because it will be uh, wired DFS. It will not be possible because if we maintain an visitor array, there is possibility that we might miss some of the vertices. So here I am iterating through via vertices but not edges. So for each vertex I am storing and of all the adjacent weights of weights of all adjacent vertices. So here you can see that. And then this is a standard procedure for finding components. Whenever uh, any element is not visited, I will start DFS and visit all the vertices which are present in same component as I. And for that I have declared uh, two vectors. One is component and other is value. Component basically stores the component number of each vertex, and value basically stores the and value of current component, total accumulated and value of current component. First I am initializing a current value with 1111 type binary representation, and here constraints are 10 raised to the power 5, so 30 bits are enough. And I'm calling DFS of on I and passing all those vectors with value by reference, and also passing this current integer by long value, also passing by reference. And after this I get the accumulated accumulator, and in current variable I will store that as the value and increase the component number. And in DFS what I'm doing is, first of all, making the visited of u equal to 1. U is our current node, and component of u is CNT. CNT means component number. I'm storing it and iterating over adjoint of u. And if visited of v dot first equal to 0, what I'm doing is I'm making current equal to taking the and of current with sum of v dot first. What is sum? And of all the adjacent vertices of v dot first, and calling DFS on child nodes. And finally, for processing queries, what I'm doing is, first of all, I'm checking if the components of both the start point and end point are not different. I have to push -1 into my answer vector. If both of them are equal, so query of I of 0 and starting point and ending point is equal, then answer should be 0. Else what I'm doing is pushing the value of component of the starting point. So yeah, that's this question. I found this interesting, and this was also trivial, but there was this age case. I think probably it was meant to have a wrong answer. So yeah, that's it from my side, and thank you for watching.